Hello and welcome, everyone. Welcome to episode 85 of DevChatter. For those of you that don't know, my name is Brendan, if you couldn't figure it out from my name being like right down here below me. This channel here is DevChatter, and by this point I'm hoping that someone has figured out that there is a live human being way up there in the corner. That live human being has a name. It's written below him. So I know, complicated. His name is James, and I'll let him tell you a little bit about himself. You should be able to talk now.
Yeah. Hi, everyone. My name is James. I am a software developer, also here in Ohio. Seems like a lot of folks are around here. And in my day job, I write a lot of Ruby, but I've also dabbled in C# as well in the past. So excited to do some pair programming with Brendan here.
Woohoo. Awesome. Okay, so
developers.
And here come the developers. Thank you for the auto host there, Code Rushed. So I see a bunch of people have come in, and I want to say welcome to everyone that's here. We are just getting started, and today we're going to be doing a little bit of a different thing than we usually do here. So we figure, we're going to do Notepad. This is our text editor right here. It's this fantastic thing. So what you do is you say like public class. No, I'm not doing this. Okay, anyway. So no, we're not using Notepad. What we're actually going to do is we're going to use Visual Studio Code, which now that I think about it, I probably should have sent you the link to join into a coding session before this point. So yeah, about that. So we'll call this Coding Games with James. Oh man, Games with James. Oh man, that is perfect, man. We might need to do this more just because of how well that works. Okay, so I'm going to get that started, and then what I want to do, for anyone who hasn't seen this, this is Visual Studio Code, and what I want to do is this. I want to say .NET New Console, and what that's going to get me a new console application running in C#. Now, we're not planning on doing all the editing here in this. This is just so he and I can collaborate. What we're actually going to do is we are going to be working on a website called CodingGame. So I have only just barely started messing with this a little bit, but this is what we're going to take a look at today, because we thought it would be fun to try out some of the coding games they've got on here. And yes, Crimson Green, this is me. I occasionally have headphones that aren't as serious. And perishable. Yeah, there's no party like a Ruby party, that's for sure. So welcome everybody. I see more people showing up. So we're going to do a little bit of coding. I think, James, you had suggested maybe doing the Mars lander.
Yeah, that's correct.
We could do that one. So I'm going to click on this. We'll get through a couple little bits of explanation and then get coding. You'll notice my progress is 0%. I have not even started this thing. Haven't done anything with it. My extent of looking into this is I opened up this page and I kind of glanced a little bit in the instructions and I clicked the go button once at the beginning to see what happens. So this website's pretty cool. I do like what they do. You'll see that in a second, Rubik's, don't worry. But our plan is, since the website can't facilitate the two of us pair programming, we're going to take the code out of the program and we're going to actually work on it together here. So that is the goal, at least. So let's go to the Solve It button, and this is where you'll see what happens. So while we're doing that, I am going to see... hang on. I'm going to get you a link, James, just so that I can set this up. Hang on. I'm going to send you a message, and then you should be able to connect into my VS Code. So for anyone who hasn't seen this, this is a really, really neat thing.
What a lovely day!
Was that like super loud for everybody? Because those were supposed to be turned off. I apologize if I just deafened everyone. And welcome everybody. Yeah, so it should be a fun one. Did you get that message, James?
I got the link.
Okay, cool.
Now. Opening up VS Code.
Yep, sounds good. So James should be connecting in right now. So let me bring VS Code back on the screen so everybody can see that. Let me know when you're in here, James. Ah, there he is.
I'm in.
Okay, cool. Yeah, we'll let it have that. Okay, so see, James is now actually in my editor, and so he's the one that just wrote that message, that hello Twitch thing. So now if I do .NET run, it should say hello Twitch. Oh, we didn't save. My bad. So now I've saved, and we'll go ahead and run that. So, woohoo. So James is actually able to make modifications to the code running on my computer, so it's really, really cool. So if you haven't seen this, this is like the new way of remote pair programming, which it's silly that we're remote pair programming because you can't be more than 10 miles away from me.
No.
Yeah. I don't think that he is right now. Should be fairly close, I think. Anyway, so here is the plan. We are going to take the code that is over here on this Mars lander. I'm going to go ahead and copy all of that. And notice, here's the cool thing. So in CodingGame, all I've done so far is said I want to do the Mars lander challenge. And what it does is I actually get a language drop down. So technically I could do Ruby, but we're going to do C#. And part of the reason why we're not doing Ruby is that I don't have all the stuff installed to be able to do that, and we're hosting it on my machine. So makes a lot more sense to do one that I could do. We could also have done JavaScript if we wanted, but I'm going to go ahead and change out our code for this one. So this now is the code that we are supposed to work on in this window, but I would rather have it out here. And Rubix, thank you for the 100 biddies. Much appreciated. Remote pair programming in the same room is actually a perfectly valid case, Coder Iguana, because you might, for example, each want to use your own keyboard, and you can pretty much sit in the same spot. The other nice thing is you can actually configure this to do a point-to-point communication, so it's not even leaving your network when it does that traffic, so you can have lightning-fast pair programming that way. And I think I've installed Ruby on Windows before, but it's not currently installed here.
Yeah, and Coder Iguana, it's not that bad now, particularly with, as Sorban mentioned, the WSL Windows subsystem for Linux. You know, that's made a world of difference there.
And yes, so James, feel free to jump in, answer any questions that anybody asks in here, either text or speaking, either way. I figured I'd mention that, so, and I will be doing the same thing. Okay, so I don't know how well you guys can read this. Let me see if I can kind of mush it there so you guys can see the text a little bit better, because here's what we're going to do. I'm going to click the play button so you guys can see what happens while we talk about this, because I did click this once before. When you click the play button, it actually takes this code and runs it. And it puts up this little simulation here. And this is what's really neat about this, is as the game goes, it's essentially running through this program. And it's a console application, which is why they can support so many different languages. And they're sending it inputs, and the program's responding with specific values. So in this case, it's always saying this first value is rotation. I read through this a little bit. And the second value is the amount of thrust to use. So right now we're saying don't rotate the ship and apply, 75% thrust basically. And that was a loud crash. Hang on one second. I can tweak that so it won't be so loud next time. There we go. Okay. So this is actually the cool thing about it. So that amount of thrust, that 3, as we know from our initial test, was not enough because it came right down onto what should have been a flat surface and crashed. Because it says, this is kind of hard to read here, Failure, vertical speed too fast. Mars lander crashed and opportunity has been destroyed in the process. So we are trying to land our Mars lander here on the surface of Mars. And that's all this exercise is. And I'm guessing based on this 80 that there are 80 turns that it plays through. And you can see the numbers as it goes. You might want to turn your volume down there, James, so we don't hear it coming from your computer either.
Turn that off.
There we go. Okay. That's true, Confused Penguin. I could just stop crashing, and then we wouldn't have a problem. But for all I know, there's audio that plays at the end in celebration when you win. I haven't actually succeeded at this one.
Neither have I.
So, we need to figure some stuff out. What do you want to do with this code? So, let's write it over here in VS Code. That was a little quieter. Still loud, but quieter. Okay, so turn it down a little bit further. There we go. So where do you want to start, James? So clearly, we're going too fast at the end.
Right.
Right? So we could just increase the power, which obviously won't work because that probably is going to mean that we're just going to spike out of control. So for example, just to experiment, because I always recommend people just experiment with stuff and see the results. We're developers. We get to try stuff.
Right.
So let's run it with 4. Is it just going to shoot up? I'm hoping it goes up. Am I going to drive it away? Is it going to go up? Come on, go up. Go up.
Go.
It's full thrust. Yeah, Rubik's. So we take the code and modify. Is that going up? I think it might be going up a little.
It's going up a bit.
Vertical speed, yeah, it's going up. It's going up. Okay, cool. So that's exactly what we expected to happen. If you give it too much thrust at the beginning, it just goes up. And let me confirm one other thing. So I'm going to lower the power now down to 2, and we're going to watch it drop a lot faster this time, I think. So take a look at the vertical speed. It has a vertical speed down that's ever increasing. That makes a lot of sense. So vertical speed is increasing. Let's print that out. So, oh, actually it's printed right here. Landing in progress, and we can see vertical speed was 90 meters per second. Okay. Let's take a look at our code here. So, what did it say for a successful landing? It gave us instructions. Right?
Yeah. So in the instructions,
okay. Vertical speed must limited, less than 40 meters per second.
Yes.
Okay. All right, we can do that. So clearly, if the speed ever exceeds that, right?
Right.
Whoops, I should be doing this in VS Code.
Okay. Got
it. Close this. Okay. So we're saying if speed what is it? It is v speed.
Yes.
Greater than what do you think? 38 maybe? If we're above 38, because we could just do that as a rough thing. Then we know we need to increase our power, right?
Right.
So. Let's make this a variable. So we're going to make this thrust. Wait, why didn't that work? Oh, just because it doesn't exist. Okay, that's my bad.
Okay.
So I'm going to put it up here outside the loop. Int thrust equals 3. And then if our speed is greater than that, then why don't you set our thrust equal to 4?
Okay. So int.
Just say thrust equals 4.
Oh, okay. Oh,
yep.
Because it's already declared?
Yep, variable is declared at that point. So James doesn't know C#, so this is why this is fun. All right, so now we're going to hop back over here. I'm going to take all this code and I'm just going to paste it right over all of that. So we're going to try this again. Yeah, so there's a lot of things we could do, Confused Penguin. I'm trying to start off simple because my assumption, and maybe I'm wrong here, is that this code will actually get... what's a good explanation of this? I'm guessing that the code is going to have us get more complicated and more difficult as we go. Because this first test case we have, test case number 1, we're landing on a flat surface, it's nice and easy, and I think we can do this. So I'm treating this kind of like test-driven development, where we're just doing the simplest thing that we think might be able to get us a safe landing, but it didn't. We're still at 59. Power was still set to 3. Let's do this.
So if you scroll down in the console output, you can see the values of v-speed and all of that in the bottom left corner.
Okay, down here.
Yeah,
power 3, power 3.
That's each step of the game loop there.
Yeah, okay. Is power the power that we set, though? It is. So it looks like we didn't ever set it. Oh, v-speed's negative.
Oh.
That's
Wait.
That's why.
Yes,
that's
it is
why.
negative because it's going, yes.
Well, welcome C# Fritz and friends. We are doing some C# coding on CodingGame right now. So, welcome. So that we want to say if it's less than negative 38. Okay, let's try that again. I'm decreasing my volume even further. Yeah, so we're doing some C# coding. Not our normal stuff. We normally do. We're normally in Visual Studio and doing .NET Core code on some of our long-term projects, which, if you don't know, all of our projects are out on GitHub. We'll probably bring James in for some other projects at some point. James, you usually program in Ruby, but you've got to know JavaScript too, right?
I've done some.
Yeah, okay. So we could bring you in for that.
Yeah.
I'm going to watch down on the bottom because I'm guessing we're going to see our console stuff come in at some point. Our power's up to 4, so... ooh, look, we're slowing down a bit too much. We might run out of fuel. Oh, it's going to be close. Yes, we did it! Woohoo! Yeah! We did it! Success!
Awesome.
Yay. Okay. So straight landing worked perfectly. So we got that. How do we get to our next test case here?
I think we probably have to... I think this, because this is episode 1, so I think we submit it.
Okay.
But copy the code first. We might want that.
It's already in VS Code.
Did you get the new?
Yeah, this is what I pasted in. I pasted from,
No,
negative. Yeah. Yep, good call. There you go.
There we go.
Our quick fix. So we'll submit this. We'll find out how it does. So next step. So yeah, that's part of why we didn't want to do everything, is because we want to go one step at a time, because it's going to, in theory, probably give us a more difficult one. Is there not a more difficult one? You gotta be kidding me, guys.
I thought that there was a more difficult one.
They've got to have us at some point land on something harder than that.
That was it?
Well, in that case, I'm glad I didn't put in the extra work in that one. Let me just try changing 1 to 2 here. Hey, there we go. Mars Lander episode 2. I just changed our URL there. Worked perfectly. All right, that's pro hacking, everybody. Don't do that stuff. That's illegal. I just hacked this website. Hey, it's Jen's Duck. Welcome back. And I see a whole bunch of familiar faces. So hopefully you are all enjoying the stream today. Don't change your don't change the URL. That's illegal. Actually, if you wanted to test for something, you do this and find out if they're like translating that into an integer and see if you overflow it or something. Anyway, so I'm going to do this again. All right, so here we are. I'm going to grab our starting code again. Actually, see, so this one's doing something different. So let's play the first test case and see what they've got us set up with. This one looks a little different.
Yeah.
Easy on the right. Okay. Ooh, we're coming in angled. Look at that. The ship isn't vertical. So we're going to have to adjust the rotation of the ship. So, all right, so we're actually going to have to be smart about this. So we have a horizontal and a vertical speed.
Okay. All right.
Yeah, exactly, not quite a Wookiee. That's one of those things people just don't think about, is that you can do that. I see this thing crashing in a moment, so I'm going to hit pause before we have to listen to the crash sound. I think we know where that's going. All right, let's take our code from here. I'm going to grab our V speed greater than that slow us down thing, and let's read the instructions. Let me just make sure it's the same. Landing information looks the same to me. Find a flat spot. And horizontal speed and vertical speed need to be limited. Sounds right. So I'm going to bring this in. So now this code looks like our last one. Oh, it was trying to rotate us. That's the only difference. Okay.
Right. Yeah. Instead of the last line being a 0.
Yep. Just make it a -20.
Yeah.
Right. Yeah. So go ahead and change that. You should be able to. All right, and now let's copy this. I'm going to trust that nothing else changed because I'm a brave man. And let's find out what happens. Oh, okay. Thank you for checking, Sorband. Much appreciated, because now I don't have to go try all those URLs. Okay, so we're watching our little ship up here, and when vertical speed, down here we can see vertical speed. When that gets over 38, we should suddenly see, and there, power just shift. So increasing thrust, power just shifted up one. Our message came out. But I think the challenge is we have thrusted too much now because we haven't adjusted our angle. And so we're getting a horizontal speed that's too much for us still.
Right.
Okay, so we can fix that, I think. So let's find out what happens. So I want to see how these numbers adjust. What is the adjustment we're allowed to make on this angle?
So looking at angle constraints, angle we can do -90 to +90.
Okay, that's a lot. So let's. I just want to do. Let's experiment. So one of the big things is try experimenting. I recommend that to any dev doing anything. I'm just gonna put a -90. Let's see what happens. Yeah, this website is free. Yes. Okay, so that puts us at. Okay, so we have full control over our rotation and where we want to put the thrust.
That's awesome.
Okay, cool. What I was wondering is just like, so that's just straight up just turned us entirely. Okay, that's cool. So at the beginning, the 20 thrust that it had us on the beginning, that's to try to get us lined up with where we want to be, right?
Right.
Thanks, so Jens Duck. You're gonna keep track of all the deaths, huh? In that case, let me hit pause before we do this because I just wanted to give the example. So before we end up with another death there, so the initial thrust of the -20 is to get us over to the right. But then the problem is our horizontal speed. Where's our horizontal speed? It's going to get too positive. So when it gets too positive, we need a positive angle. Right?
Right.
The next question that we've got is how do we detect where that solid ground is? So, did they give us that info? Coordinates of a surface point. That's our target. Isn't it? So how do we find our target? Flat ground landing site. There's a unique area of flat ground on the surface which is 1,000 meters wide.
All right.
So we need to find that.
3 seconds. That's the free fall stuff. Yeah.
No, Farrell, we haven't tried JavaScript yet, but we absolutely could. Nice, Sorband. I actually did to learn how this website worked, I actually tried a Batman one where he's jumping around and trying to find a bomb on a building. It was actually kind of fun. Not very difficult, actually. This one seems much more challenging.
Yeah, for sure.
Okay. So I'm going to pull this to cover up the screen a little bit more. Let's take a look at our code. So what do we have? So initially, it gave us all the surface coordinates. And so there should be a spot where all the y values are the same. So that should find us our landing zone, right?
Yes.
Yeah, so if people are wondering about language, there are a lot of choices. So this drop down, so if you're not comfortable in C# and want to try this also, they have VB.
Oh, they've got...
Whoa! You gotta love how I'm not surprised by any of the... they've got, what, like Pascal in here, and I'm amazed by the VB. That does say something. What's VB look like? Oh, not bad. Okay. Anyway, switching back to C#. Oh, hey, cool, it saved our code. I thought it might lose it if I switched off of that. Okay.
There it is.
So we need to find where that... So, okay, maybe we should start with simplest thing that works. Let's not find that spot. Let's just go there. So here's what I'm going to do. I'm going to move us forward. This will be the spot we want to target. So we'll say we want to land about here, right? That X value?
Yeah.
Okay, so we're just going to hard code this in. We're not going to find the landing pad yet. We'll write the code to do that in a moment. Because I don't want to take the time to figure that out. So the X coordinate is right here. So 4550. So when we get to that point, that's when we need to target that point. Actually, can I just find it? Let's find the width of it. So it's from about here, so from 4,000 to, we'll say from 4,100 to 5,100. We'll give ourselves 1,000 meters to land in. So we'll call that our safe zone. Int safe safe zone start equals 4,100, and then int safe zone end equals 5,100. Yeah, so I saw that 1,000 Sorband, but this seemed to be what we ended up finding there. So we'll take a look. We're going to give ourselves this range to kind of target. And we'll write something that helps us find that later. So actually, let me do this. Find the zone with code. Duh. Okay, so we're gonna do that eventually. For now, okay. So what do we want to do with this? We need to see what our x coordinates are and what our speed is, right?
Right.
And then we need to slow ourselves down. So yes. I think the idea here is we need to say, oh, awesome! I just noticed S&B picked up a DevChatter tall mug. I will need to... I actually haven't even gotten mine yet. I still need to order my own. So I will have to show this to you later, James. You're going to laugh. Okay, so our vertical speed is that... okay, why don't we actually put in our other safeties here? What are our speed limitations for landing? Our horizontal speed is limited to 20, so we need to be less than 20. So let's put in the same kind of check for that one. And for horizontal speed, it can be either direction. So let's do h speed. And what is it? Is it, maybe someone remembers. Dot absolute, yeah, there it is. Math.absolute h speed. Oh, no, because we need to know either direction. We need to know what it is. So we'll say if it's less than, what do you think, 18?
Yeah.
Slow the heck down. Or
well,
hang on. Do something.
All right, so looking back at it, 20 in absolute value.
Hang on, horizontal speed. So to the right is positive, to the left is negative. So to the right is a positive horizontal speed. So negative. So going left, need positive thrust. And then let's do the reverse now. We may need to write these into some methods instead of just having them in here at some point, but let's just put this in. So going right, if we have a positive value, need negative thrust. So that's actually not I should say rotation.
Rotation.
Right. Rotation. There we go. Okay. So we need our rotation value pulled out. So I'll extract this. You just create rotation there. So just go ahead and use rotate. Okay, that works.
No, I can't use rotate. Rotate already exists.
Okay. In that case, use rotation. I'll make rotation.
Rotate is the value of our...
Yeah. So rotation, 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 rotation. So it started at -20. So why don't we just, so we need positive rotation. And this needs negative rotation. Why don't we just always do 20s for now?
Okay.
So we'll do positive and -20. Now this code won't work, but it might be able to get us a little bit further. Okay. Let's see what this does. Oh. Hey, nice. Let me adjust to that text. We're not increasing thrust. We're what is this? This is change to pos rotation, and this is change to neg rotation.
Yes.
Okay. So at least our debugging messages will help us if we see them. Let's try that again. Okay, hopefully everybody's ready on those death counters because we're dying again. We know this. It's okay. This is welcome to coding. The sudden jerking movement of from -20 to +20 on this rotation is going to look hilarious, I think, when it kicks in. Is it kick? Shouldn't it have kicked in already? Horizontal speed.
I think it did.
I haven't seen it kick in yet.
No, it hasn't.
Horizontal speed less than 18 or greater than 18. Isn't H speed above that?
H speed is 86 right now.
Wait, did it flip right there at the end or something? No, it just crashed.
Yeah. So H speed was 86.
We were way above that. Speeds are positive. Oh, no, Sorband. They can be negative. Here, look. See, our vertical speed is -38. It's kind of hard to tell there, but that's -38 on that speed. And the horizontal speed going to the right is positive. Right. I think if we go to the left, it's negative. Yeah, maybe. Thanks, Jen.
Do we have it backwards then?
H speed is going. Oh, yep, we have it backwards.
Okay.
Wait. Oh no. This was supposed to be if it's greater than 18. Hang on. If it's.
So looking at it.
Going right need. Wait, hang on. Going right need positive rotation. Going left need negative rotation. So the comments are now correct. If we're going right, that means we have a positive one, so that means we're doing greater than 18. And if we're going left, that means we have less than -18. And we need a negative rotation. I'm going to put this back in VS Code while I run that. So there we go. Sorry about changing everything on you. Let's watch this again, because I think we had that backwards. Yeah, don't worry, guys. Not applying to SpaceX just yet. Hey, guys, as I told you, 2 simple steps. So, okay, that looks like it's slowing us down. Okay, good. So this is our landing, that's our, initial landing procedure adjustments. Obviously, this is a terrible set of adjustments. See how it's like flipping us back and forth? Actually, that wasn't terrible on the landing. Like, were that a flat surface? That wouldn't have been actually that bad.
No, that would have worked.
So, sounds good, Jens Duck. Yeah, that actually wasn't that bad. Yeah, that worked better than I thought it would. So now what we need to do is we need to start by getting ourselves into the right location. So this is like our landing code. I'm going to make us a method down here. And I'm actually just going to say static void. Do we want it to be void? Prepare for landing. Landing. Okay. Actually, do I want to do something horrible? Guys, internet, do I want to do horrible things? I think I want to do horrible things. Let's do horrible things. I could do the code the right way, but that doesn't sound fun. Someone's gonna kill me. Terrible things I wanted to do for fun. May fix later if feeling less evil. Else evil? Less evil. Okay. So here's what we're going to do. We're going to do prepare for landing. Prepare for landing is going to be an action named prepare for landing. And I'm going to set it equal to this code here that is lovely. And no one will kill me for it. So there's our code. I'm going to, yes, I'm doing horrible things. Horrible things. All right, so welcome to a lambda expression here. We now have access. How you do lambdas. Yeah, so we now have access to thrust here. So we could just, do whatever we want with it. But this is prepare for landing. So I'm going to take this code we just wrote here. And I'm going to take all of this. I'm going to put that in our prepare for landing. I don't have those yet. So here's what we're going to do. These variables right here all get declared in here, but I want them up there instead.
But then they won't be getting updated.
No, they're still going to get their values.
Oh.
They'll get updates. I'm just going to create them early.
Oh. Okay.
So that we have access to them.
So you're changing the scope.
Yes, I'm increasing their scope up to the top. So these 2 variables are now scoped up to the top. So they're no longer scoped to the loop. We created them up higher. They can still get used down below because methods in C# will allow us to get away with that. So the idea is up here we create these things, and then down here they get new values set each time. And that's fine. But what it lets us do is just have them in here like terrible people. Actually, you know what I could do to be less... No, I'm going to be less evil. I'm going to be less evil, guys. I'm going to use fewer closure crazinesses. We're just going to do this. V speed, H speed. Wait, what? Oh, sorry, my bad. Action of int. I'm like, wait, what? Why did everything just red squiggly? Okay, so, yeah, C# is actually a really fun language to learn. Sorband, I really appreciate it. Okay, why not just increase the thrusting to like 10 and reduce to 4 again when it reaches the V speed? Oh, so Pyro, our maximum is actually 4. So But this is our prepare for landing. So when we're preparing for landing, we need to start calling this. And this is what levels us out, slows us down, and things like that.
Right.
So I need to recreate this. Whoops. Int. Okay, let's make sure this code works if I just call prepare for landing again every time. And what was it? V speed and then H speed?
Yes.
Okay, I'm going to paste this in. We're going to make sure it works. Remember, don't try to write all your code at once. Just run it and just see if things, just make sure it works. So code seems to run. We didn't have any compiler errors or anything like that. So user. So the horrible thing is that I decided to do a lambda expression, use closures to access the values. So the concept is this. So I have these thrust and rotation values that I am accessing just in here in this method. So that's allowing me to modify them down here when I call it. So it's kind of, it's not exactly the best code. I just did it because it was kind of fun and I wanted to mess with James. Because, why not do some terrible things in C# while you have a non-C# dev with you on the stream?
Little does he know that this is how we do things in Ruby all the time.
Oh yeah, no, I've seen Ruby before. Okay, so we need to find the target. Suggestions for finding the target, James?
Yeah, so we have access to our X and Y on each step of the loop. So we should be able to, let's see. So we should be able to figure out where we are on the, and I'm going to go back and look at the map real quick. We should be able to figure out where we are on the X axis, and then we can initiate a landing procedure the minute we're over the target zone.
Okay.
So going back to Visual Studio Code here. So we will need to set rotation and thrust. What was the starting value for rotation? It was 20?
Negative 20.
Negative 20?
Starting value, yeah, negative 20.
And then thrust was equal to
4.
Was it
3?
4?
3.
Yeah.
Sorry.
Okay. So we'll start off with that, and then let's see.
If our X and Y coordinates aren't in the safe zone, we need to target them, right?
Well, so there's two ways we can do it. There's the naive, just solving for this exact scenario way, and then there's the actual pathfinding.
True.
What are you thinking of?
Since we're starting off facing that way. Hang on, let me do one thing real quickly. Sorry, everybody, we're gonna blow up an extra ship here. Let's click on the next one of these. Okay, so yeah, see, now it wants us going the exact opposite direction, changing entirely. So looking at that, it's gonna send us the other way on the next challenge. So since we're immediately gonna have to do that, we could code that one in, but I think we're better off doing initially trying to find it.
Doing a find? Okay, cool.
All right, so why don't we call this move to target, target, and we'll pass in our, actually, you know what we could do that'd be a little bit nicer? Hang on. All right, okay, I need to find out what version of C# they have us running here, because I don't actually know. So let me do this real quickly. All right, so we need rotation and thrust. So I am going to set rotation, comma, thrust equal to -20, comma 3.
So
let me see if that blows up. If it gives me a compiler error, then that's a different circumstance. It does not. Okay, perfect. We can use tuples in C#. Fantastic. I just wanted to make sure that we were, like, this needed to be on version 7 at least. So here's what I'm going to do. We're going to do find target. Move to target? We said move to target.
Yes, because we've got prepared for landing.
Okay, so move to target, and we're going to set rotation, comma, thrust equal to move to target. And the values we want to pass in for move to target are our speed and our X and Y, right? So go ahead and pass those in.
Yes.
Type those in and I'll start making the method we're going to call on this.
We just want H speed and V speed?
Yeah, and our current X and Y should be. So we're going to say static int, comma, int, move to target.
And then looking up in the around line 18, it looks like we actually get the land driven for or drawn for us. Is that what that's doing?
Console, that is the X and Y coordinate of each spot of land across the whole thing, as I read that. So that's giving us this entire line, all the flat and all the angled bits.
Right.
And basically, we want, like, if we want to do the find our landing spot, we're looking for a sequence of matching Y values.
Right.
So we would want to just loop over that and find, like, all of our Ys.
Right.
Yeah, so Pyro, we're probably also going to want current rotation, and thrust, things like that. But for now, we're going to start a little simple. Again, with all these things, we're trying to start simple because we could handle like everything related to this bot, or this lander. But that is probably over what we're trying to do just to solve this problem. Okay, so coming down here, so we have move to target. Wait, why did it? Oh, sorry. Move to target needs int h speed, int v speed, x, int x, int y. Okay, now we have our parameters, and this needs a return value. So we're going to say -20 and 3. So that is our rotation and thrust. So I'll say new rotation equals -20. And int new thrust equals 3. So now new rotation and new thrust, right?
Right.
So now that code should work. I'm just going to so feel free to continue looking at it, but I'm going to paste it over here and make sure it works, even though it doesn't do anything yet. I just want to make sure that it compiles and everything. Yep, works fine. Good. Okay,
and it does
there's
the
our
same
compile
thing.
check.
It does? Okay, cool.
Yep. So this works, which means our... So for anyone who hasn't seen this, we have tuples and deconstruction of tuples in C# now. So this method actually returns 2 values, and we deconstruct them into these 2 variables. So that means this rotation and thrust value are stored in this rotation and thrust when the method returns. So for anybody that already knows C#, this is a new feature in C# 7. Our old tuples were not as good there, James. C# wasn't known for its tuples. Okay, so what did you want to do with move to target? What was your thinking?
So my thinking was we would want to find the safe zone. I know
I hard coded it. Yeah.
Right. We'd find it. Start with that. And that's in scope. That is not in scope.
Hang on. fixing. Yep. So just add those in, and then we'll be good. Okay, cool.
Okay.
Yep, that works. That works.
So we know where the safe zone is, and then we want to make sure that we're headed that way.
Sounds good.
So, all right. So we're going to want.
So the thing I like about a move to target method is that if we later have to like dodge a peak as we're flying, you know, like this method should still work whether we're trying to get to the landing zone or trying to avoid an obstacle. Move to target should still work as long as we know where our target is.
Right.
Okay.
So let's see. That'll be a little more interesting when we get there.
All right. So we let's start with an if, right? What's our if? What do we want to do with this?
What we'll want to do is if our current and safe zone start is along the x-axis.
Yeah, so it's our
right?
x-axis is the one we're looking at right now.
Yeah. So if x is
greater than the start and less than the end.
How do you do ands?
2 ampersands.
Okay.
Yep, there you go. See, the thing I love about it, I was pointing out is before we started the stream, James was mentioning, he's like, I don't know, C#. And I was like, yeah, it doesn't matter because you know what to ask for. And so, like, you just need syntax.
Right. So we check to see if we're inside the safe zone.
Yep, if we're inside the safe zone, then we want to get our horizontal speed down to 0.
Right. So in that case, this is where something I spotted earlier comes into play, which is we can set our rotation to whatever we want, but the angle of the value is limited to the value of the previous turn plus minus 15. So we can't spin on a dime. We're limited per frame.
Oh, okay. But I think if we pick a larger value, it seemed like it was self-limiting to that. And doing a slow rotation, it would eventually get us there 2 frames later.
Yes. But what we tell it to do will not happen instantly. It could take a bit depending on where it is right now.
Okay.
So we can set. So the first thing we want to do is basically get. We want to be right above the target zone, and we want to stop our rotation. So.
Oh, sorry.
Oops. So new rotation. We'd want to set that to 0.
Yep, sounds right.
And then, well, before we get any further with the thrust, we want to try and make sure that this logic actually works.
Sounds good.
So if you can put that into the
move to target safe zone. So yeah, we'll make sure it compiles, but there's no way it works yet.
Oh yeah, sure. We didn't call move to target yet. Yeah, we did.
Yeah, we call it, but I don't think it actually gets us there yet.
Oh,
also, we're preparing for landing every time too.
Yeah. Well, but we have the initial values, right? We have our initial rotation of minus 20 and our initial thrust of 3.
I love watching this ship auto-correcting here as it's like adjusting its way down. I love watching its little wiggle as it does to get itself down to the bottom.
And
Not
impact.
bad.
Almost.
Not bad. We almost unintentionally got there. So that wasn't.
Looking at our horizontal speed, we were 19. Looking at our vertical speed, that was 40 or 39. We almost landed.
Yeah, if we'd gotten into the zone, we might have unintentionally landed. Okay, so you're thinking drop it to 0, but then when we're going for our landing, we're adjusting as well. We need to get our H speed down to 0, though. Right? We need to get our horizontal speed to 0 so we stop shifting around.
Right. Well, but then what's prepare for landing do? Prepare for landing.
Prepare for landing, I think, is focused on the X value.
Well, there's V speed, but then there's also some H speed stuff. But yes, you're right. So prepare for landing shouldn't actually do anything until we hit the conditions. So maybe we want to set our new rotation. So if H speed, see, we went through this earlier with H speed. So if we want H speed.
You know what? I'm going to adjust our prepare for landing. I'm going to adjust its rotation values down a little bit.
Okay.
Hopefully by the time we're preparing for, well, I don't want to call prepare for landing until we're getting close to a landing. So I'm going to adjust how we call this. Let's not call it until we're close.
Okay.
Do we have what our height is? We have our Y value.
Yes, we have our Y value.
So what's our Y value right before the crash? Y value was 313 on this one?
Yes.
But that's not accurate. We need to be lower. So how about if we start adjusting for landing when we're into our last, say, 1,000 meters?
Okay. That should be enough.
So last 1,000 meters, then we'll start preparing for landing. So prepare for landing. So we're going to say if y is less than or equal to 1,000, then we'll start preparing for landing. Otherwise, if we're not preparing for landing, then we're going to do our standard move to target. Does that sound good?
Makes sense.
So we'll prepare for landing, and hopefully we've already gotten on target.
Yes. That's the hope.
All right, so let's, wait, we're not compiling yet. What am I talking about? We had incomplete stuff down here. Okay, so we want to get our H speed down to 0. So how are we going to do that? I'm going to look at our prepare for landing code because it was targeting a low H speed also.
Yes. So if H speed.
Hang on. I'm just going to paste in from our other one.
Okay.
Because this we know does slow down, so we can adjust how we do that. So set the new rotations based on those.
Okay.
But actually, since this is trying to slow us down, we want an even bigger adjustment because we want to get ourselves stopped. So
right.
If we're even more than like 10, we want to be shifting, right?
Yes.
Because we've found our spot. We want, so the goal is that like hopefully we roughly find the place that we're targeting. I'm going to adjust this one to be down to like 10 also. So we're going to adjust both of them down. So we're going to be more active about fixing our rotation. So let me paste this in. I'm going to go run this. Feel free to keep changing code.
Okay.
While I'm doing this, I just want to let it run so we can watch what happens. Okay, so coming in, it is shifting over to the right like we expect. And I don't want to see it making any changes until we're in there. Theory Master. James is hopefully writing some code in the background. Huh? What do you mean? What's he doing?
See, so we've got.
Oh, that's funny. That was amazing.
Oh, but what happened?
Look at where it just crashed.
Oh, wow.
It was right here. The Mars lander did not land in a vertical position and crashed. So, all that means is that when we get to this point, we need to reset rotation to 0. So,
So what was our current rotation at that point?
well, it's whatever we left it at here. So why don't we say prepare for landing? Hopefully, let's just try setting rotation to 0 and prepare for landing.
Okay.
And we'll see what happens. I don't know what that's going to do. And yeah, I'm just leaving it commented out for now because we might need to put something back in there. But let's see. So it looks like... Yeah, so Sorband, what I'm planning on doing is adjusting the rotation based on the height, but I don't have that value in there yet. So we need to say, like, based on where we are. Okay, we're just going too fast in our horizontal speed at that point then. Because we triggered into landing too soon. So let's adjust when we start landing.
Okay.
To say 700. So we'll land a little later. Any other suggestions for how to land a little bit better there, James?
Yeah, so looking at landing. Where'd it go? There it is.
Oh, so here's the problem. I'm coming in, and then my horizontal speed, and it increases, I think, still. Yeah, horizontal speed starts increasing. Right here, I'm betting. No, we just haven't slowed it down enough.
Oh, because we set it to 0. We need to counteract it. We set our rotation. We got our rotation to 0, but we need our we need to get it slowed down further.
Hang on. I think we need these. I think in our move to target, I think we need to move faster. And slow down better.
Slow previously.
So once we're inside the target zone, start slowing down, is what we're saying. I don't think we're slowing down fast enough. So we got into the target based on our initial trajectory that we have hard-coded in there of heading to the right. And then we get into that spot and we haven't slowed down enough.
And then here.
And then we're still coming in too fast. So here's where we stopped. Right about here. So altitude just hit 700, and then that's when we straighten out. But we haven't slowed down enough by the time we got to that point. And we needed to.
So we did 20 that time.
I think the moment we get in, we need to suddenly be like, whoa, nope, you know, and stop ourselves. Alternately, we could slow down the amount, the speed that we use to get in there, and we could adjust our new rotation, our initial rotation, to just be smaller. But we'll try this. We're gonna go big or go home. Let's do big rotations, lots of thrust, and just come on, man. What do you think? All right, so let's see. We're gonna fly in here, slow down, and what are we going at? Our horizontal speed's still too high. Okay, so that's not gonna work. Let's slow ourselves down. I'm just gonna adjust it to 10 and try it again. I'm gonna go a little bit slower coming in. What happens? Do I just not go fast enough then? Wait, hang on. Oh, we're going to go slightly too fast still. But look at how I just barely dodged that thing. That is funny. Okay. So I'll let that run. Yeah, change new rotation to 15, and let's try tweaking when we prepare for landing down to 600. We'll give ourselves a little bit of extra time.
Right.
And let's get this running again. There we go. So we're running with rotation of 15. Let's zip ahead a little bit because that's just taking too long. And now it's about to be on target, but our speed's still increasing. So we need to, so it should flip right here, but we might be too low. Yep, because we then go into landing mode. So we didn't adjust soon enough. So what we need to do is we need to say we're getting close to it and start slowing down. So
there's almost a, there's prepare for landing, which seems to work pretty well. But then there is
our move to target's not quite right because we just go like speeding towards the target. We're going too fast. We need to slow down as we get to it. No. He's just another C# dev. He's another awesome guy. Oh my G4. This is James. He's a Ruby dev, so we have him write in C#. So it's been kind of fun. Yeah.
So something that might be worth doing is changing our thrust, because bring it down from 3. So we're going slower overall, because if you look at what was going on there, we were going too fast, and our rotation.
Hang on.
It's the
Let me take a look though. The problem is, if we do that, our vertical speed's also too high then. So, because we need thrust amped up before that point. We're going way too fast vertical. So we have 2 problems right now. Both of them we're needing to slow down. So I think in both of these respects, we need to get our thrust pointed away and firing up sooner.
Okay.
So,
so
here's what I'm thinking. If H speed, right? If it's positive, we're going right. So we need to figure out how to slow ourselves down. So it is what's it measured in? Our horizontal speed is measured in meters per second. That's the number of meters. Is this seconds? Hang on. 47. Hang on, let me click this one time. 4526. Yes. Okay, so here's the secret that I just the secret sauce. I figured it out.
What'd you find?
Each one of these steps is a second. Okay? So we know where we'll be next tick. So that means we can just add our horizontal speed and know if next time we're going to be out of it, right?
Oh, okay.
So we can use a multiple of our speed to say, hey, I'm about to be in the safe zone. Maybe I should slow down.
We can look ahead of it.
Yeah, so why don't we do this? Expected... I'm just going to say future x equals x plus... And why don't we say 3 times h speed, right? So I'm just going to, whoops, I'm typing this in the wrong place. I'm going to go put this in VS Code so you can see it.
Much appreciated.
So, there we go. So in future x equals x plus that value. So now instead of doing this, we want to see is the future x inside of that zone. Right?
Right. And
so that will get us slowing down early. 3 turns
Right.
early, basically, we'll start slowing down. How much thrust are we doing? We're going to a rotation of 30 to slow us down, and we're using a thrust of 3 every time. Okay. That's fine for now. We'll see how that goes. We might find out that we need to adjust it further, because we could just say if the H speed is absurdly high, kick the thrust in hard. We might have to just throw up to 4 and be like, thrust was over this, slow the heck down, what are you doing? And yeah, I know we're kind of hard coding these in here for now, but we'll see what we end up with. Okay, so I'm going to speed that up. That's taking too long. So we got here. Hang on, where did it start slowing down? So right there. Okay, so right here is where we start slowing down.
Okay.
And you'll notice we're not quite over it just yet. And then it starts slowing us down, and then straightens us out, but we're not yet to our horizontal speed. So it looks like we just needed to maintain it a little bit longer. So here's what I'm going to do.
Well, that's when the prepare for landing function kicks in.
Yeah, so why don't I do this? I'm going to make one other adjustment and prepare for landing. Oh, you got it. Put it down to, say, 300. And yes, Pyro, we're probably going to end up doing something like that eventually. Yeah, so, and the really neat thing about it, oh my G4, is that I'm actually the only one here that is a professional C# developer. James is an unprofessional Ruby developer, but aren't they all? But aren't they? No, I'm just teasing, man. No, he's a professional Ruby developer. I was just... What's the matter? You didn't see that one coming?
No.
Oh, all right, guys.
I don't have a comeback to that one.
All right. So let's watch this thing go. Here it goes. Coming in. Let's see what happens. All right, it's slowing down. I'm not sure it's going to slow down enough. Nope. Crash!
No.
Wait,
Pyro, it's a little wrong. First X, save some N needs to be the other way around.
Wait, what?
Pyro said something in chat about future X, safe zone start.
Oh, yes. He wrote some code. Yeah, his little snippet. He must have gotten something backwards.
Or his snippet. Oh,
yeah.
Okay.
That's why I had to add the comments on ours, is because it's hard to keep straight, like, wait a minute, is positive right or left? Which one is it? So it's hard to figure out. So change to positive rotation, change to negative rotation. So get our H speed to 0. Okay, so we didn't thrust enough here. So
we can't turn it up to 11.
No. Hang on. I'm putting that there. I'm going to change this new thrust when we're doing an adjustment. So only do it. Yeah, there you go. So put that in there. So we'll increase when we're trying to fix things only. So increase thrust to fix, but not normally, because we don't want to get going too fast. So let's try that again and see what happens. So now it shouldn't kick in the bonus thrust until we're... Oh, hey, look, it takes an extra turn this time. It takes 2 extra turns. We used to take 74 seconds to land. Now we're going to take 76 seconds to land.
Is that when we run out of fuel?
I don't know, but we... Oh, no, we're at 22 and we're still going too fast. So our vertical speed and horizontal speed are both too high. Wait, what?
Do we want to kick it in earlier?
Yeah, we could kick it in earlier. You're thinking, like, change our future X value?
Yeah, because this is in... So
just change it to, like, 4 or 5.
Let's do 5.
Okay. Rubik's, we are We're getting close to landing here. We're doing some interesting stuff. We're just tweaking right now. We didn't do like a super complex approach, but we've got an idea of what we're going for. Yeah, the death total is clearly over 50 at this point.
Yeah.
She's totally correct. All right, she. Jen's duck. No idea. Hang on, slowing down, but we are not slow enough. We're still going too fast. Okay, our horizontal speed is okay. It's our vertical speed now that's got us.
Okay. And then our angle, we're rotated.
It's been getting counted the whole time there, Rubik's. We were rotated?
Well, we weren't rotating, but we need to rotate. If you go back one frame to second 76.
Rotation's at 0.
Oh.
Angle's 0, we're fine.
Oh, sorry, I didn't catch that.
Yeah, no, we straightened out. Yeah, exactly, Greendorf. A Kerbal could have survived this.
Absolutely.
Okay, so our horizontal speed's good. We need to slow down our vertical speed a little bit, which I think means we need to get into position a little bit faster. Rubik's, I do have Kerbal Space Program, and I'm a big fan of it. It's a fun game. So what's your thought, James, on how we can get this? Stronger rotations and then earlier thrust. Yes, exactly, Pyro. We need to get ourselves in the right direction and slowing down sooner.
Right. So by doing that, let's see, looking through the code again.
Move to target. I think I want to start us with an initial rotation of -30. So we'll thrust in the direction a little bit sooner. And then why don't we look ahead 8 turns, and then that's when we'll start slowing down with stronger thrust, so that our thrusting,
right. So directionally, we'll have more time to.
Yeah.
I don't know the term. I didn't do orbital mechanics.
Yeah, I don't remember it. And actually, for people who are wondering about the possibility of some kind of a gaming stream at some point, I probably will do something at some point. We'll see. Whoa, we get there way sooner now. We must blow up so much faster now.
No. Horizontal speed's pretty much perfect.
Once we get vertical speed under, once horizontal speed drops below 20, once it's below 20, we need to go 0 and straighten up.
Right.
Okay. So that's the answer. If less than that or at speed and on target. I'm going to make a method at speed and on target. We're going to have to give it some parameters. Can you pass it the parameters for that?
Yeah, so at speed and on target, it's going to need V speed, H speed, and then
it needs XY. It needs our safe zone
everything
stuff.
to move to target.
Yeah, so give it all the same stuff that move to target has. I don't think it actually needed V speed, but that's fine. At speed and on target. So, because actually, what I mean by at speed and on target is H speed is correct. Okay. So let's leave out V speed.
V speed.
So we have H speed, X, Y, safe start, and safe end. Okay, cool. So now we're down here, and we want to return true. So that code ought to work. No, I'm just kidding. All right, so yeah. So we want to say if X is greater than safe start and X is less than safe end, then we're on target. Actually, hang on. Yeah, so that's on target. So hang on. So let me just make that our return. Whoops, that our return. So that, so we're there, and actually the first one should, I wrote it as speed and target, so we're going to start with speed and target. So h speed is less than 20, or h speed is greater than negative 20, right?
Yes. And then all right, so we're returning. Sorry,
Yeah,
I'm trying to
as
wrap
Crimson Green says, I don't like games. What's that? We're returning this?
Okay, so this will return a true or false?
Yeah, this whole thing is going to return a true or false for
Okay.
whether we're within these conditions. So that's we're going slow and we're within the target zone. And if so, I now want to make sure, we'll prepare for landing. So we're either below this point, at which point we prepare for landing regardless, or or this one triggers it, and we'll prepare for landing. And landing will set our rotation to 0 and kick our thrust, and it'll probably kick our thrust up.
Right.
If it's less than, and I'm actually going to adjust the V speed trigger just to make sure that we don't accidentally go over. If we're going faster than negative 34, I want full thrust.
Be interesting to see how this one goes.
Yep. So this one's going 75 seconds. So, okay, so it comes in, starts slowing down, and straightens out. What happens when it straightens out? Hang on, so we're slowing down, hang on. And then it straightens out. Why did it straighten out? We must have messed up the logic on that. Let's take a look. Did I get something backwards? I'm going to remove our tweaky adjustment stuff from ready for landing.
Looking at it.
We're at speed non-target. XY start. Because H speed needs to be less than 20 or... Oh, wait, hang on. And.
Oh. That will always evaluate to be...
Yes. That was going to always be true. So basically, as soon as we got on target, it was like, oh, we're done. So let's start watching from here as we get close. And it should keep on slowing us down. Keep on slowing us down. Keep on slowing us down. There we go. And now it straightens out. Oh, but we can't get our vertical speed down enough. Vertical speed's still too much.
And what was our thrust at? Was it at 4?
Yeah, our thrust is up to 4. It's been at 4 for a bit. So maximum thrust just isn't enough. We came in with too much force. So we need to be slowing ourselves down sooner. I guess 10?
Look further ahead every time?
Yeah, look further ahead for now. We're going to be there within 10 moves. Let's slow the heck down. So, let's try that again. All right, let's jump forward. Where do we start triggering? So, this must be where we said, okay, 10 turns ahead. We're going to be there, so it changes rotation. It says, yep, we're going to be there soon. Start slowing us down. Now the question is how early... Okay, it actually gets us into the correct speed way earlier than we need to. So you know what I want to do? I want to get our thrust more vertical earlier. Our thrust is too much of an angle, right? So here's the problem. Like when our thrust is like this or like this, we're not getting enough vertical slowdown. So let's change our new rotations. Because we've got them at 30, let's change them back to 20. That way they're fighting, yeah, get that one. That way they're fighting the gravity a little bit more earlier and dealing a little bit less with the x coordinates. So start helping us with V speed more sooner.
Right. I think we made an extra turn that time.
So let's find out what's happening here. So we are at thrust 4, pointing mostly up, trying to slow ourselves down. We might not be slowing enough this time around. Slowed, straightens out, but oh, at 42! Well, there's the answer. We're done. We're at 42. 42 is the answer. We all know this.
It's the answer to the question.
Yeah, so that's actually kind of close. So it looks like at the beginning we just didn't go fast enough getting over here. So our initial rotation was 30 and 3.
Right, for the thrust.
Then we start slowing down at 20 and 4. And that isn't quite enough.
But we don't want to change the rotation to 15 because we're just...
Let's not go over so fast. Let's do 25 instead of 30. And maybe with that, we won't get ourselves going that direction quite so fast. So we might be able to start going vertical with our 40 thrust sooner, and that ought to slow us down. Rotation 0, speed less than 40, and H speed less... Yes, exactly. Yep, that's correct, Sorband. Yep, successful landing conditions, we need no rotation, and we need to be at a V speed less than 40 and H speed less than 20. So our 42 was close. Okay, so horizontal speed needs to come down quickly, which it is, but I don't know if it's going to be fast enough. There it is. Okay, we're below that. Now get that other speed down. No, 41! 41!
No!
41!
1 meter per second.
1 meter per second. Yeah, I know. 1 meter per second. That's how little we missed it by. All right, so how do we tweak to that? Now that we slowed down, well, how slow did we get our horizontal speed? Do we have wiggle room on that? No, we don't have any wiggle room on horizontal speed.
We don't. We could raise the axis that we do that on. So we're still doing that on 300. So if we start a little bit earlier, well, but we're already starting as soon as possible with the at speed and on target.
I would still say rotate faster and let it thrust.
Oh.
You're thinking kick in landing sooner there, Pyro, but we're kicking in landing once we've slowed down our horizontal speed enough. Okay, so I'm watching this coming in. This might actually do it. We're down below horizontal speed. We're down below vertical speed. There it is. Dunk! Woohoo! We landed.
Perfect.
There we go.
That was cool.
Perfect. We're good. Okay, so one test case down. So now here's the tricky part. We need to not break this as we do our future ones. So, all right, cool. Stage 1 down. Oh, the test case turned green, so I knew before the animation. Well, thanks for that, Sorband. I hadn't noticed. But yeah, 19 and 38. That is like just barely within the acceptable requirements there. That's pretty good. Wait, I'm silent? Why am I? Pyro, I shouldn't be silent. Can you guys not hear me? You guys can hear me, right? Seems like my audio went down. I'm confused by that.
People hear me? Quiet, not silent.
Hang on, how about now? Is that any better? I don't know. Well, in that case, I'm going to quiet James down. So I have no idea why I suddenly got quieter. microphone settings.
Sorbin says you've been going up and down all stream.
Oh, I bet I know what it is then. Hang on. Hang on. Okay, is that any better, everybody? Let me look at my own little thing. Yep, that looks better. Yes, there we go. Okay, cool. James, talk for me for a second.
All right, I'm talking.
Cool.
And
audio's been adjusted back. I'm now the loud one. I apologize about that. I will adjust my audio down just a hair, and now we should both be able to talk. Woohoo! Hooray! Thank you for the heads up, everybody. No, there was a different problem. So, but audio sounds good. Let's run our next test case, and we're gonna watch it fail horribly. So it's heading for that, and it's got the wrong target because we didn't program it to understand the target. But that would be hilarious if it landed successfully anyway. So where's it going? What's it doing? That does not look right.
Dude, not.
Watching that thing go, it's like, seems a little confused. Let's speed it up. Okay, it's going to get there, and then it's going to crash. Boom! All right, cool. So we need to find that target. So let's still play our original test case, because I want to program in that we need to find the target now. So that's the thing you were wanting to do before.
Right.
Let's find it.
Okay.
So, in the beginning, we got this set of surface n, which is it says surface n number of points. Okay, so that's the number of points. This is this is the coordinates. Okay, so it gave us all of these, but then we did we put them into inputs 0 and 1. Okay. So they gave us those. Int parse inputs. Of a surface point split. Oh, okay. So it's putting them in that array each time, and it's doing nothing with them.
Right. Yeah, we're not using them anywhere.
Okay. So let's do this. Let's do a... I'm assuming they're coming in order.
I think that would be a...
So I'm going to do an int array that we're going to say are y values equals new int array, and its size is going to be 7,000 because that's what they told us is the... Although I should set it equal to surface n, so let's do that. Surface n, and then y values are going to be x equals land y. Why is it not like that? Oh, land x. Whoops. Land x equals land y, right? On my array. So basically, whatever the coordinate is inside that array, we're setting the y value.
Okay. So is this in C#? Are these normal? Are you said it's a in.
This is, yeah, so this is just an array. Standard, like, contiguous memory array. Think old-fashioned crummy kind. That we have more advanced ones, but this, we know the exact size of the container. We're not adding or removing values from it. So an array makes sense here, I think.
Yeah.
So old-timey arrays. think like a C array.
Nothing that tries to be a hash.
Yeah, nothing fancy. Nothing fancy. Contiguous set of values. Okay, so these are the y values. So what we want to do is find where the... so we want to find the safe zone. So here's what I'm going to do. I'm going to change this into a tuple. So we're going to say int well, yeah. Well, we're going to find the new one, so we'll find it. Safe zone end and equals find safe zone, passing in the y values array. And I'm going to save this just in case we need to reference those for some reason.
Potentially.
Okay, so there's our tuple, int safe start zone, int safe zone end. And then that method we need to create. So let's go down here and make a new method. Static. And then this is going to be int comma int find safe zone, and it's going to take in an int array that we're going to call y values. Oh, you have to duck out soon.
Yeah.
I just noticed the time.
I've got 10 minutes. So.
Okay. So this is going to be safe start and safe end.
And then looking at it, the flat ground on the surface of Mars, which is at least 1,000 meters wide.
Okay, that works.
So it is at least that wide.
So we have our variables declared up there, our safe end and our safe start. I'm just going to set them equal to 0 for now. Because that is the starting point on the left, I believe. It starts at 0 and goes up. So we need to find our x value. So, so we're going to say for each int y value in y values. Yep, you got it. We want to do something with this. We want to say previous. So previous equals y value is what we're going to do each time, right?
Right at the end.
Yeah, that's why I put my cursor above it.
Yep.
So at the end of each loop, we're going to set the previous equal to this one, and we're going to say if we match the previous, then keep counting from this point. Level count equals 0. So we're going to say if I can't type apparently. Don't worry about me. So we're going to say if the y value equals previous,
then we'll want to do
level count plus plus.
Or
no,
just
plus plus, yeah. And then what we want to do here is we want to say otherwise level count gets reset. So level count equals 0 and continue on, right?
Yeah, that's cool that you've got plus plus. We would do.
Yeah, same thing C# C++ does. Only the nice thing on ours is you might remember from C++ days that yeah. So Sorbin, some people do plus equals 1. The nice thing with C# is that the compiler will check to see whether or not you could have done value plus plus or plus plus value. We support both of them, and the compiler will usually figure out whether you can use the one that's more performant or not. So one of them is faster than the other. I forget why. There's some very specific language changes, but yeah, +=1. That's the common one that all languages support. That pretty much.
Yeah.
Some equivalent of.
You fancy people with your compilers.
Yes, Coder Iguana. Yes, it'll do both. And the nice thing is the compiler will fix it if you did the wrong one. So, because it can usually tell, it can look at it and be like, you didn't actually use the advantage of having it one way or the other, and it will put in the one faster. Yeah, ++I runs before, I++ runs after, but I don't. But there's like an optimization with it. I don't remember what it is. The compiler just automatically chooses the right one for you. Okay, so what did we do? We said find that, and actually the first time we do that, so this just finds that, this just knows that we're on the set and we've started counting, right? So what we could do is we could say in here, and actually I'm just going to put it in here instead of doing another layer. We're going to say if level count was greater than or equal to 1,000, right? Before we reset it back to 0, then that means that whatever x value we're on. Oh, I don't know the x values. Dang it! Ugh. Son of a gun. All right, yeah, all right. We got to change this. We have to do it differently. So 4.
Well, we could pass in x values as well.
Yeah, we could, but we don't need to because they're in the array. Position in the array is our x value.
Oh, yes.
Yeah, position within the array is the x value. So x, I'm going to rename, instead of doing a for loop on I, I'm going to do a for loop on x because it's going to make more sense that way. And we're going to say y values dot count, whoops, not count length. Sorry, it's an array. Then what we can do is take this code that we wrote down here and merge them. And then instead of that, it's y values at index x. And this is y value at index x. There we go. So now what we can say is, when we got to this point, we can say, actually, we can return right there.
Yeah, we could break.
That's where we return. Yeah. What do we don't need to break. We can just return.
Oh,
if we return from inside of a loop, it automatically breaks you out of the loop. Welcome to C#.
Well, yeah.
Yeah. I assume it does that in your language too.
I guess from a stylistic perspective, I would break and then I would explicitly return.
Yeah, we can here.
No, we don't need to.
I'd rather go right here. So we need to return x minus 1 as our ending point. So 0, comma, and then x minus 1, right? Because we're no longer matching. Right?
Right.
And then we need to do x minus level count. We're going to be off by 1, but I'm not worried about that.
One smaller?
What's that?
Will be 1 smaller, the count?
Yeah, I think we might be off by 1. So I guess we could say minus level count plus 1 or something like that. But I'm not too worried about it. And that should be safe for the most part. If we get down here, then we had an error.
And then we'll be returning 0 and 0.
Yeah, in fact, I'm just going to hard code 0 and 0 then. And I'm going to say, and I'm going to record an error. Error, right line. We're going to say, didn't find a landing zone, ... Because that's pretty bad if we get to that point. And you got rid of my variables. Awesome. Thank you.
Yeah, because we don't need those.
Yep. Cool. All right. Let's copy this. Let's see how it does.
Well, we won't be able to tell because we're not outputting Are we all putting find safe zone?
Hey, that was awesome. Check it out, guys. Look, we blow up immediately now.
Whoa!
Watch. We must be throwing an exception or something.
Index was outside the bounds of the array.
Yeah, so at line 25, right here, whoops. Y lands land X. Oh, because I created it, but I didn't actually make it that big. Yeah, okay, that's fine. That's fine.
WYSIWYG, this might be an unpopular opinion, but people who say JavaScript isn't a real programming language need to actually write some JavaScripts and learn that it is.
Yeah, JavaScript's a great language. It's just a great language with a lot of horrible things about it.
It's got some issues, but overall it is far better than people give it credit for. So comparing Ruby and JavaScript, literally comparing two very different things. You know, it is apples and oranges, or coffee and gemstones.
All right, here's what we're gonna do. We're gonna do a list events. Instead of that, using system collections generics already at the top. Nice. Oh, whoops, new. And then instead of doing this, I'm gonna say I'm just gonna trust that they gave these to us in order. Why does it not know that that's can do that? I don't know why it was not giving me any autocomplete on that. Find safe zone.
No,
okay.
It picked it up for me.
Yeah, okay. IEnumerable of int. So we're going to do an IEnumerable instead of an array, which means I now need to use count on that. And I'm going to use an IList instead of an IEnumerable because I'm not an idiot. Don't be an idiot, Brendan. And James, don't worry about the difference between what I was just talking about.
All right.
One of those, really the difference is that one of those has an indexer and the other one doesn't. They're interfaces that could accept both an array or a list. So either way that we did it. Either way, we're not blowing up right away this time.
That's good.
I would love it if the program had printed out right off the bat where it was gonna, where it thinks we should be landing, because it's gonna crash. So let's have it do that. Console error right line, and we're gonna say the safe zone is, and then to that. Okay. We're going to try this again. Uh-oh. Didn't find a landing zone. Well, we found out why it crashed last time. It didn't actually find a landing zone. I wonder what the values look like then. So here's what I'm going to do. Let's print out some more console error things real quickly down here, because I need a debugging value. When it resets, what did we get to? If the y value equals the previous y value, no matter what, always set the previous y value equal to the current one. Anything look wrong here? And no, Sorband, I don't think assembly devs think that. Yeah, French isn't a real language because it's not old enough. We need languages that are at least, 10 to 20,000 years old.
So Latin?
Probably some others too. Oh, that's a good question. So let's do 500. Let's just put that in there. We'll just not. It's supposed to be over 1,000, but let's just put that in there and see if it gets it. Didn't find a landing zone. Yep, it doesn't find it. So we apparently messed up something with our landing zone finding.
Okay.
So we check to see. What's that?
I will have to leave in like 2, maybe 3 minutes.
Okay. Yeah. That's not a problem. I will say bye when you need to leave, and I will keep writing code.
Okay. So looking in this safe zone.
Yeah, so we start off at the beginning of the loop, and we check to see if our y value matches the previous. If it does, we count it.
Are we doing any counting?
What's that?
Are we actually doing any counting?
I don't know. Let's find out.
And then it takes a string. Okay, cool.
Yep, just takes a string.
And then for string interpolation, you showed me that earlier.
$sign at the beginning, and then curly braces, and put in the value.
Okay, so we want...
This is what I was talking about when I was saying the fact that, like, James doesn't know C#, but I fully expect a professional developer to be able to write in another language as long as they have someone else there that knows it and can just be like, yeah, here's the syntax you need.
Right.
It's really cool. So, because he's like, he knows that there's a string interpolation in here. Like, he's seen it. And he just doesn't always remember the syntax. Previous y value. It should be the y value.
Y value? Yes.
Yep. So change that to a y value. And I'm going to save this, copy it, switch it over here, paste it in here, run it again. Okay, whoops, gotta pause, gotta back up. Okay. Previous y value was 150. Looks like it did that once.
So it found something level once?
Wait, hang on. I just had a thought. We might be idiots. Hang on. Because I need to do one thing. Error.writeLine. And then, yeah, we're about to find out if we're idiots, everybody. Surface N. So, hang on. I'm actually going to make that a string just so we're clear that we're idiots. If is less than 1,000, we're idiots. So that's what we're going to put in there, everybody. And we're about to find out when the program tells us whether or not... yeah, exactly, Pyro. I think it's like 5.
17.
Pyro hit it exactly. What was it? I didn't catch it.
It flashed just for a second, but I think it said 17.
If 7. See, it is. We're idiots. It's not giving us all the points. It's giving us these. So that's the problem.
Oh.
Yeah, we're not getting the individual dots. We're just getting the corners. So every corner. Yeah, exactly. We're just getting... Yeah, yep.
We're looking for 2 corners.
Oh, man. Hang on while I toss some derps in there, too. Because derp. All right. So, let's change up this code a little bit. We're no longer doing lists of ints. We're doing lists of ints. So we're going to do, those are going to be XY coordinates. So this is going to be an int. Whoops. Brendan, what was that? That doesn't make any sense. So, and now in here, we're going to do add... so we're going to do land X and land Y. So we're going to insert these into the collection now instead. See, it says coordinates of a point. And, oh wait, hang on. By linking all points together in a sequential fashion, you form the surface. No, see, that's not the way I would describe that. They're giving us the, you know, like you can imagine there's a line between each point.
Right. They're giving us the dots, and then we have to play connect the dots.
Yeah, basically. Okay, so... so
Sorry
this
to fail.
now... Yeah, that was a major fail on our part. That's
No.
fine, we figured it out.
Yeah.
Oh, and those are not X, Y. These are... we'll call it land values for now. That's the best we got. They're not exactly land values, but that name kind of gets it across.
Yeah.
So land values, I'm going to rename that. So land values, we're going to call it X and Y, just so they're not crappy. So we're going to say land value.y equals that, and then down here, land value.y. And then if they're the same, instead, so we no longer need to do this counting that we were doing. We actually just need to say, oh, and previous actually could be an int previous. This was the previous coordinate.
Okay.
So previous coordinate. And I'm going to switch this back to a for each. Don't worry about adjusting around that too much.
Okay.
For each item in land values.
All right. Well,
Yep.
I'm out of time, so.
Yep. You got to go. All
Yep.
right.
Thank you very much. This was fantastic.
Bye. Look, I'm waving up at you. Thank you for stopping by and streaming with us.
This way.
Hopefully everybody enjoyed having you here. Take care. We will see you around. Don't worry, everybody. We're going to keep writing the code. Thanks, James. Later.
Thank you. Later.
All right, now to actually clear James off the screen. Hang on, I got a little bit of James smudged on the screen here. Let me just clean that off. Pair programmers. So remove that. And just smudge that. There we go. Oh, there we go. Cleaned, fixed up. All right, everybody, give me 1 second while I bring everything else back. We no longer have James, so we need to bring back all the fun stuff. There we go. Excellent. And now, to do this. Yep, we're going to click that button. Look, music. There we go. Fantastic. Alright, so now that James is out of here, I'm actually going to boot him out so he doesn't do stuff while we're doing this. How do I kick him out? End collaboration session. There we go. Now he's been booted. Okay, so now, instead of this, we just have item, which I'll change the name of that in a moment. There we go. And I apologize about the beeping and everything there, guys. Getting the audio fixed up here. So audio should be in the background. I should be talking. We should be good. So if item equals previous... Previous equals 0, 0. Cannot be applied to int xy and int xy. Why not? Because they don't have the right signature? Alright, we'll do this. If int x, we'll say if our y equals this dot y, so if the y values match, then we say that this is it, and item dot x minus item dot we're gonna say previous dot x plus 1000 is less than or equal to item dot x. If the previous x plus 1000 is less than or equal to x, then return this value. Then we want to return previous dot x and item dot x as our coordinates. Otherwise, we want to continue on. So if the y value matches the previous one and the distance is that, then we can return. That sounds good. You don't need to care about the x. I doubt they're going to make level troll people like that. What do you mean, Pyro? Let me take a look at, what's he, wait, does C# run on Linux on the box? Sorbend, yeah, you can run .NET Core on a Linux box. What has been anything with this happen since run? I didn't know that, David. But yeah, Silverlight wasn't as bad as people like to say about it. What I meant is that I doubt they're going to add a segment with the same Y value just to throw people off. Oh, 2 in a row, you mean? Yeah, that's probably true, so I probably don't need to check this. But it should work still all the same. So I'm going to copy this over, and we're going to see what this comes back with when we run it. Pause. Back up a few frames. The safe zone is 4,000 to 5,500. Fantastic. Also, I'm going to get rid of that comment about idiots thing, because I don't need that anymore. Alright. There we go. Oh, and check it out. It turned green. So, like was pointed out to us, when it's going to succeed, it turns green, so we actually know in advance that we're going to succeed. So it levels out, starts slowing down, decrease speed, so, and we land. So perfect. Let's take a look at the other direction and see what happens. Getting is prevented by destabilizing Visual Studio for 2 years. Oh, yeah. Okay, so it's coming in fast. Our horizontal speed's still way up, so looks like we're not going to be slowing down enough in this one. So I think we need to start factoring in what that horizontal speed is and increase our rotation if the horizontal speed is too much. No! No, it stopped! Okay, good, it came out. Okay, so it's trying to land too early. Did you guys see that? It tried to land too early. And then we can't recorrect. We can't recorrect. Okay. So we need to see how close we... Oh, man. That wasn't bad. That wasn't bad. I don't totally mind that. That's not the worst thing we've seen. Yeah, so if H speed if the absolute H speed is greater than 70, we need to slow down a little more. So let's go ahead and do that. And we'll do that on our way there. So, not define safe zone, but move to target. We're gonna say that I'm just gonna put it in like this for now, even though it's not the best way to write it. We're just gonna say if h speed math dot absolute value of h speed is greater than, say, 50, 60, 50, then we're gonna say new thrust equals 4. We'll do 70, because that's if we've really gotten out of control. We should speed up. Yeah, sorry, Chillax. You can't post links in here. We do block those. So I don't know what you were posting, but whatever it is, it won't be allowed in here. All right, so we're gonna recheck the first one because we don't want to. We want to get step 2 without breaking the first one. Okay, so it looks like it's still running because it turned green. But let's check out this one. Okay, so this still crashes. Let's see why. Horizontal speed. So we've got that thrust at 4. That should be slowing us the heck down. Now our thrust should have just dropped down. Okay, so our thrust is still at 4. Okay, are we on target now? I think we're not going to land fast enough now is the problem. So when we watch, I think we just don't land. So we're coming in here, and it switches to landing procedure, but we're still way the heck away, and we still have a horizontal speed. So at speed, why don't I call this ready for landing instead of at speed and on target? So I'm going to rename this method. We're going to say, I'm going to click the wrong button. Ready for landing. So that's our new name for it. I'm going to cut that because that's going to be part of this now. We're going to say if it's... We're ready for landing only under these circumstances. But then I want to say and y is less than, say... I don't know, what's a good number? 300 for now? Let's see if the beginning's still break. So we need to check case 1, because we might crash this now. Okay, so case 1 is still working. So it still lands just fine. But then we'll check the other one. Yeah, so Pyro, we're going to need to start adding in some more logic into how we actually build this. So we're going to need to adjust for our safe zone a little bit better. And I think the problem here is we're kicking in that ×4 a little too early. I think we need more rotation. So we're fighting the horizontal speed more than we are fighting the vertical speed. Yeah, exactly. So we've slowed down enough by that point. And, oh, see? It just straightened out, but we haven't adjusted down our vertical speed yet. So there's the annoyance. Right here, we triggered that way too early. And y needs to be less than 300. We're not ready for landing yet. Y is not less than 300. Why did that trigger? That shouldn't have triggered. Oh, because I didn't paste it in. Oh! Helps if you actually paste it in there, Brendan. Imagine that. We're going to recheck this. Again, I need to make sure I didn't break the initial one. Oh, I broke the initial one. Okay. So there's the crash, because we didn't switch into that mode soon enough. Hang on. We said y is less than 300. We're inside the safe zone. We're slowed down enough. Needs to be less than 400, we'll say. Brendan, it helps if you paste it in. Still gonna crash. Why is it crashing? And y is less than or equal to 300. You're thinking that that's going to work. We're inside the safe zone. Our speed is fine. We should be ready to land. Yeah, but what doesn't make sense is I don't get how that's different from our previous code. It feels like our previous code. So I'm going to put this back up here. So let's save this line. Let's back this up a little bit. We're going to put this back to the way it was. So we're going to leave that up there. We're going to put that down there. So we're saying if we're ready for landing, or we're basically at landing, we better straighten out. So were we doing that before we were ready? But that doesn't make sense. Yeah, but I thought these other values would be true. That's the weird part. So I'm going to put this back in. It's going to green again, I think. No, it doesn't. Well, that doesn't make sense to me then. Was it seriously this that was succeeding before? It wasn't that code. It wasn't the 300. Yeah, it's not that. That's funny. This is not what it is. So that is the code that passes right here. So I'm removing the piece that we're not actually using, and this should still be green. So that 300 requirement is what kills us. So what happens here at the end? So we get on target, and then it straightens out and starts just working on the vertical speed, because it is fixed enough of the horizontal. So I guess what we can try to do is we can try to So let's find safe zone. What are we returning? So find safe zone, ready for landing, move to target, gets us back, rotation and thrust. Okay, so why don't we phrase our methods a little bit differently? So we have these methods right now. I kind of feel like I want to do a static int, comma int, and say get stop horizontal movement thrust. So we're going to say get thrust to stop horizontal. So we'll say get thrust to stop horizontal is what we're expecting to do. So we'll return back 0, 0. Why not try my snipped? Oh, yeah, Pyro. I will definitely try that code. I'm assuming your code is designed to do what I'm doing right here. Yeah, let's take a look. Because that code's not ugly. All in one line like this. Alright, so you did math min of math max of these values that are all squiggly. So we need to say int x, int y, int safe zone start, int safe zone end. Math min of math max to this and this and this. Okay. Alright, where's this end? That. So it's either 20. So I'm going to call that foo. Int foo equals this. Just making your code more readable for me. And then that is bar. Don't worry, I'll name them in a second. I just need to see what I'm working with here. So what are these pieces? And what do they do? So if x is greater than our... So if we're past the safe zone... this is right of safe zone. To right is right of safe. Bool is right of safe equals that. Then we do safe zone end minus x. Or x is nested ternary. Okay, here's the next one. Is left of safe. Bool is left of safe equals that. Then, so this one, do that or do that. So how much? So this is find the. So this right here is also a value. This is how much we're off by. So bar is distance from safety. Appears to be what that is. If we're right, then it's greater value minus the... Wait, is that backwards? I think that might be backwards, Pyro. X being greater than the end means we're to the right of it. X being less than the start means we're to the left of it. So we're saying if we're to the right of it, then we want to take it. It should be X minus that because X is the larger number, right? If we want to find our distance. Correct me if I'm wrong about what you were trying to do here, Pyro. So that's if we're left of it. So you're saying the greater of those two values. Okay, so basically what you're doing is you're trying to get, do we need to be negative or positive, and then adjusting to that amount. So this is not the distance from safety necessarily. We could do that, but then we'd want to positive or negative it. So the adjustments, because going left, we need negative numbers to go left. So if we are right, so we need a negative number. Okay, so yes, I get what you're doing. We need a negative rotation. Distance-based rotation is what we'll call that, because this value is a distance-based rotation based on that, and then we can go to either that or that, and then really you're just doing this. So we're going to insert this into the value here. We're going to inline it. So this is cap to -20 to 20 based on that value. So there we go. Got that. So then, you're suggesting that we take this rotation value, return that as the rotation value, and our thrust as something like 30 or 40 depending on our speed. So, int v speed, int h speed gets us those values. For now, I'm just going to return back a thrust of 4. So that's get thrust to stop horizontal. So we're saying so we're suggesting doing this instead of that one. So we're saying rotation, thrust. I know this isn't perfect yet. We still need to adjust, but I just want to see if it works. H speed, V speed, X, Y, safe zone start, safe zone end, and there's our value. So there's our new one. This is a new way of doing things. We're going to put this in here. We'll give it a shot. Let's check it again. Let's see if it breaks. Nachos, you have a question. Looks like we're going to crash here on the first time. I'll let that run. Should you go into programming as a QA tester first, then you work your way up to becoming a developer for a video game? Oh, that is a good question. So specifically for video games, getting in is sometimes harder. I think we might have our directions here backwards, Pyro. Currently don't have much experience in programming as you're still in school. Are you in school for programming? Any advice on how you can overcome any difficulties when it comes to coding, and also what does one do on the job as a programmer? Okay, yeah, no, I would be glad to talk about that kind of stuff, Nachos. So, the life of a programmer is an interesting one. We end up solving a lot of problems. Yeah, so as Sorban points out, game devs are not always paid that well, and especially for the amount of hours that they have to put in. So I know a lot of people that are dedicated to going into game programming, and some of them usually like it. But I will tell you, as a programmer, a lot of time you spend digging through, reading code, and trying to solve problems. So if the text on my screen right now doesn't sound fun to you, programming's not always that fun. Programmers on big games aren't usually the ones that are like playing the game all the time. Usually the one that is playing the game is someone that's working more on the game itself. A programmer's usually doing lower level things. Computer science is fun, Nachos. Programming is fun. So, are we supposed to be doing X minus that? I don't know. It seemed like we went backwards. Maybe I was wrong. I don't remember. Pyro, we might be backwards, and this is the problem with coding sometimes, is that sometimes the code just doesn't make sense. Yeah, we're just going the wrong way. Totally going the wrong way. Because this doesn't make sense to me. Is right of safe, is left of safe. So let's do this. Because I just want it to be clearer so I can read it a little bit better. So is right of safe. So if we're to the right, need positive rotation. So need positive rotation to point left. Need negative rotation to point right. Okay, so that gets us set up. So what I want to do is this. I want to say int rotation equals 0, and here I want to say rotation equals so we need positive. If we're right of it, then that means that our x value is larger. So x minus safe end, and this side we want to do safe, so we are left of it. So rotation equals start minus x started at 0. So then we're going to say rotation is capped at minus 20 to 20, but we'll take this value if we can get it. And actually, I'm going to write this as an else if. And the reason why is that I want to handle the third case. I want to say else if h speed So I want to say if h speed is greater than 1, is less than -1, and I want to slow us down a little bit. Oh, that's awesome, Sorband. You're making a switch from tech support to web development. That's really cool. So, one recommendation I would give to people, I notice there's a bunch of stuff talking in chat, is make sure that whatever type of programming you get into is something you enjoy. So I like a lot of different types of programming, including web development. And I know that there are a lot of people that don't like the languages that you do for web development. They like lower level languages, some like higher level languages. So with a lot of things in programming, you just need to find the area that you like, which is kind of funny to tell people like, hey, you've been looking for what career you want to do in your life, so now you found that. Now we're suggesting find where you want to be within that career, because there's so many different things. And that's one of the big things. So Rubik's actually just pointed out a big thing that people don't realize, is you're going to spend a lot of time doing stuff that's not actually programming. So you're going to have to coordinate with people. You're going to have to learn about the domain. So if I want to build banking software, I have to learn all about banks. If I work so I've worked for legal companies, so law companies, and I've had to learn a lot about that. I've had to work with banks. I've had to work with finance companies. I've had to work with oil companies. I've had to work with schools. I've had to work with e-commerce companies. I've worked with other software vendors. And I have to learn a lot about all of their different businesses in order to do that stuff. Nachos, so if you like lower level languages, you should definitely learn C++. Although I will also tell you, I liked, so I do still like a lot of lower level languages, but that's not where I want to be doing my coding most of the time. Because I also like the higher level languages. So my recommendation to you would be try a bunch of stuff, find out which ones you like. Because you might like more than one. So don't settle on one just because you found one that you liked. So that's what I would tell you. There are a number of companies that do low-level language programming. Lots of them. And it depends on where you are in the world and which ones exist. So I can't really give you recommendations on that. Learning assembly can be useful depending on what you actually are planning on doing, but even that it's becoming rarer. That's true, Pyro, but the low-level languages are already pretty close to that. So, okay, so here's what we're doing. We're saying H speed is less than that, so positive, right. So if positive, you counteract positive with positive, and you counteract negative with negative. So if we're positive, then we maybe want to do a positive, and if we're negative, we want to do a negative. And actually, maybe we'll do smaller. You know what I'm going to do? I'm going to set it to the H speed. Because I can do this. Math.absolute value of the H speed. So we're going to say no matter what it is, if that's greater than 1, then we're going to do that. So we're going to set it equal to the H speed because we already cap it to 20. Nachos, if the stream locks up for any reason, you can usually reload the page and it'll fix it, but if it does lock up for a long time on me, let me know and I will try to fix it. Yeah, so as David's pointing out, you can learn it if it's interesting to you and it's fun, but there are not going to be many jobs where you're going to use it. It's very rare. You're going to want to look mostly at C and C++. That's where the majority of the jobs are going to be. Yeah, see, Sealed Killer also points out you also want to make sure that you're lined up with jobs. So in some areas, there are not many jobs for certain things. So if there's a place you want to live, make sure they've got jobs for, whatever you're planning on doing. In my area, for example, there are a lot of Java and C# jobs. There are Python and Ruby as well. There's plenty of JavaScript. And if you love C++, stick with it, Nachos. C++ is a great language. So I am a big fan of C++. It does a lot of fantastic things. So let's run this again. Let's see if we fixed this one and improved ourselves onto the next one. Okay. So we're doing an entirely different approach. And it looks like it's still just going the wrong way. Something about that is just not right. So what I'm going to do is this. I'm going to turn this back on. We're going to start thrusting towards the place we want to go to. So I'm going to turn this back on. We're going to run it. That should turn green now. So this is using our previous code, and the previous code works. So we kick our thrust into the negatives to go to the right. Very nice, David. Very nice. Yes. That is true, Rubix. I approve of C, C++, C#, Objective-C. They're all great languages. Okay, so here's what I want to do. So we said if we're ready for a landing, then we'll prepare for a landing. But I want to add something else. I want to say if speed will take us out. So I want to say x, and so I want to say h speed, x, and our safe zone start and end, passing those in. So we're going to say static bool speed will take us out. Then what we want to do is we need to correct. So I want to thrust to stop horizontal. So that's when we're going to trigger that. We're going to say if we're going to leave, so if we know we're going to leave, landing Y. I need to know the landing Y. Int X, int Y, our landing Y. So we need to have Y, and then we need to have our landing Y, which we got when we got our, we could have gotten from our safe landing Y. There we go. So we're going to go to our find safe values here, and we're going to do one more int. So it's going to return an extra value, and that's going to be item.y. So we need to know what the level is, how high up we are when we're going to crash, and that's what we want to fix. So, and I do want to thank all of you for chatting and answering questions about all that stuff. One thing that I may not have mentioned to everybody is that DevChatter very much is a community. It's not just me, so I'm really glad that everybody's chiming in with all this good advice. And if you do want to chat with any other people that are here in DevChatter, one of the best places to do that is actually to join our Discord, which I just linked in chat there. There are actually a bunch of us in there talking about coding, developers, stuff like that. So, yeah. What's it? Oh. Yeah, so I was thinking the same thing, Hannibal, but it didn't look like I did. I think I had it in the right order. Oh, V-speed and H-speed, get thrust to stop horizontal. You are correct, I did. Good call, Hannibal. You found it. You found it. That was the problem. So I'm just going to return false from now, so that'll turn that off, and we'll try that code again. Let's take a look. Let's see if Hannibal spotted the issue. We'll see if, so it doesn't land yet, but at least hopefully it'll turn us in the right direction? No, it's not. It's still not turning us. So no, Not doing it. Alright, that's fine. So we're going to put it back the way it was. So we're going to see if speed will take us out, then we're going to try to do this. So I want to say int, what do I say? What do I do? H speed then V speed? Int V speed. So I want to say distance to land equals y minus landing y. So that's our distance. So if we say, and I'm okay with integer. Yeah, we'll be wrapping up the stream at some point. I don't know exactly what I'm going to wrap up today. So let's store this as a float for now. So we're going to have distance to land as a floating point number. And I want to say distance to land divided by my v speed. Math.absolute v speed. We're going to assume that I'm going down. Sorbend, yeah, we probably should. Float, float, x equals that. I don't want x. What is this? This is the turns left. So I want to say turns left times h speed. So our h speed, this will get us distance float projected distance equals that. So that's our projected distance. Yeah, exactly. So the challenge I've got here is that I almost wish I had my own unit testing package that was apart from theirs. Like, I wish I could test locally and keep writing in VS Code, which isn't ideal. So x plus projected distance projected destination equals that, and then I want to return projected destination speed will take us out, so that means greater than the end, safe end, or projected destination less than safe start. Either of those is the case, so we're either after the end or before the start, then the speed is going to leave us outside of the range. So we're ready for the landing, but we're not going to be able to land in it. So h speed, v speed, x, y, safe start, safe end, landing. There we go. Yeah, if we don't end up making it much further with this stuff, then that's fine. We'll be back to our regular streams on our next one, so don't worry too much about that. For everybody who is wondering about what we're going to be doing here on the streams going forward, if you are new or anything like that or don't show up regularly, first off, there's a couple of things that I will mention, and that is you can follow me on Twitter. You can follow DevChatter on Twitter, or you can follow me on Twitter at Brandonius right there. Nope. Yeah, we're gonna need to fix that one. But anyway, so what I was saying is, you can catch me there. If you want to see our old videos, they're here on Twitch. And then if you want to see anything that's more than 60 days old or 30 days old or however many days it is that Twitch keeps around in the videos section, you can actually find all of our old archives out on YouTube. But we actually have a cool stream that's coming up here soon that I want to tell you all about before I do anything else. So if I didn't mention, all the code we do here on the stream is usually stored out on GitHub, so all of our projects that we do, they're at github.com/devchatter. And the thing I want to mention is we're doing a special stream on Thursday. We're going to have a guest here talking with us, so we're actually really going to do some dev chatter. And we are going to be talking about how to engage the developer community. I'm bringing Cassandra on because she is another expert in, getting involved in the developer community and doing those kinds of things. That's sort of what she does. She gives a lot of advice to other people on these ideas, and it's something that I think is valuable to a lot of developers, probably also you. So if that sounds fun and interesting, this is practically like going to a conference talk here, and we'll probably look at things, pull stuff up. I don't know if I'll convince her to write code, but my plan is, I haven't talked to her about how long she's going to be able to stick around, but if she is here a while, cool, but if she does have to duck out, I will start writing code afterwards, because I have some neat things that I'm working on. So here around the screen on me, as anybody knows, we have an overlay that is actually there that is controlled by our bot, and we want to start building stuff for that. So as you notice above my head right now, I've started messing with things, and we can trigger, stuff happening. So that little hype guy shows up there and starts moving around. And what I want to do is actually start really animating in some stuff that the bot can control. And so doing some interesting things with that. I have some neat ideas, and we're going to be doing that coming up here soon. Also, for anybody who doesn't know, if you want our schedule, so you want to know when we're going to stream, you could do something like this. You can actually type in our chat !schedule and put in a city, state, country, whatever, it'll search and try to find that for you. And it'll find a time zone and respond back with that. So you could say, for example, schedule Germany. And it'll tell you when our schedule is for Germany. And yes, Sorband, it will tell you a time for Mars. And in fact, it's going to give you UTC if you do try to troll it with that. If anyone hasn't yet, I do recommend that people click that follow button to get notified of stuff. But I have another event that I want to make sure that I tell you all about, because it's a cool one. And actually, I'm going to do this to bring it up. So, on August 11th, which is Saturday, right here. So one of the series of streams that I do here on DevChatter, for anyone who doesn't know and is new, is our Learn to Code in C# series. So today we've been at a pretty high level. We're assuming everybody understands C# programming and things like that as we code. However, sometimes we like to do our Learn to Code series here, and our Learn to Code in C# series is designed for beginners. So people that are just learning how to program or just want to learn C#, and we welcome all of them to show up, and we go at an easier level. Now we've already completed 5 episodes of this series, which, by the way, if anyone did want to go here, they could go to this event, and they can actually watch all the videos up to this point and attend on the 6th. Or on the 11th, and show up to their 6th episode. Shane, thanks for following. So, our Learn to Code series is actually really fun when we get a lot of people that show up for them. We have a bunch of beginners that show up that are learning how to code. Some are in school, some are just transitioning jobs, some just think programming is a cool thing and want to learn it. And then we also get a whole bunch of people that already know coding that show up. And so, while I'm answering questions and things like that and talking about things, there are people in chat also chatting away and answering these questions, so it makes for a really fun stream. So hopefully we'll get some of you to show up for that, and it should be a good time. And then the other thing that I want to tell everybody about Did I make a solid yet? No, I didn't. Okay. There is another set of streams that I am setting up. We are going to start doing solid Saturdays starting in a couple of weeks. And you'll notice that I've got them set up down here. So here they are. So the whole concept behind these is that we want to have a series of streams on the solid principles of object-oriented design. So we're going to be looking at each one and giving each one a full day, and we're going to talk about it. Each day is going to have a little bit of overlap because it's impossible to talk about any solid principle without talking about the others, but we will be doing this and it will be a lot of fun. So that should be good. So if you want to catch these, make sure you click the Remind Me button over here, and you'll actually get reminders specifically about these events. So that's separate from just following the channel. So if you don't want to follow the channel but still want to get reminders, you can do that there. And then other than that, I think we're going to wrap for the day. So thank you everybody for showing up, chatting, and if you do want to engage more with our community, the best way to do that is to check out our Discord. And I just linked that over there in the chat. And Discord, for anyone who doesn't know, is a chat application. Think Slack, but for gamers and Twitch streamers. And there are a bunch of us over there that are always chatting about different coding stuff. So if you do want to chat with us outside the stream, that's the best place to do it. Nice, Sorband. I think we'll get through that one. We just need to figure out how to make that one work a little bit better. There's a couple of changes that we're going to have to do in order to... We need to figure out better control of the ship. But we'll get it working if we stick with it a little bit longer. Other than that one, I wanted to thank everybody for showing up, chatting, and hanging out. Obviously, thanking James, who is no longer up in the corner, but he was awesome and fun to program with. We got a bunch of people that followed today, and I want to thank all of you for following. It was a really good stream. We had a lot of people show up. And for anybody that cheered or did anything like that, subscribed, in any way supported the stream, I want to thank all of you for that. So we really appreciate it, as it makes the stream possible. And anyway, current coding game contest is super fun and a month long. If you're into games, is building a Hearthstone-esque game bot. Oh, that could be really fun, David. We may look into that. But either way, next week we will be back to our regular programming where we are working on our chatbot. And specifically, what I want to do is I'm going to start adding the commands where you guys can start manipulating stuff that happens on the screen up there. So that's a lot of JavaScript and SignalR talking with our C# backend. So our C# website is actually our bot. So it's going to be a lot of fun, and I hope to see you all there. So have a great rest of your day, everybody. Happy coding, and I will see you all on Thursday when we talk with Cassandra Ferris about engaging the developer community. So it should be a blast, and keep in mind we start a little bit early on Thursdays. So bye everybody, have a good one. Oh, Horkrine, yep, we're just ending. See ya. Bye everybody.